Welcome you all for the session of finding mathematical induction concept. So for that, you're having a problem. Prove by induction, prove by mathematical induction. Summation I equal to 1 to n, 1 by I into I plus 1 equal to n by n plus 1 such that n is greater than or equal to 1. Okay. So we need to solve by using two rows. First one is base case. For base case, we need to have assume n equal to 1. So for that LHS, we'll take an LHS. So summation I equal to 1 to 1. 1 divided by I into I plus 1 will take only 1. So 1 divided by 1 into 1 plus 1, which is known as 1 by 2. And next we'll see RHS equal to n divided by n plus 1, which is 1 divided by 1 plus 1, 1 by 2. So here we prove LHS equal to RHS for base case. Now next we'll go for induction step, right? Induction step. For this, first here we'll see the two cases. Let n equal to k. Summation I equal to 1 to k. 1 divided by I into I plus 1 equal to k divided by k plus 1. So if it is true, we have to prove this value for n equal to k plus 1 also, right? Now, so that is the second point. If it is true, we have to show. Now let us assume the equation is true for n equal to k and check if it is also true for n equal to k plus 1 or not, right? Here n equal to k plus 1 will take. So LHS summation I equal to 1 to k plus 1. Why? Because n equal to k plus 1. So 1 divided by I into I plus 1. So for that we need to have this term summation I equal to, we'll split the term into two terms. So I equal to 1 to k, right? 1 divided by I into I plus 1 plus we'll have then another term which is known as k plus 1 and k plus 1. So this is the second term, right? So this will be replaced by the formula, the given formula, which is like this, right? So it is exactly in the format of n by n plus 1. So this term. So that's why we'll replace like so. Hence it is k. In terms of k, we'll replace by k divided by k plus 1 plus 1 divided by k plus 1 into k plus 1. Right? So here it is k plus 2. Sorry. Why? Because k plus 1. So the next term will be k plus 1, and into k plus 1. So that's why here you are having k plus the next term k plus 1 into k plus 1 which is known as k plus 2. So that's why here also k plus 2, right? Okay, now we'll take a LCM for this. You are getting k plus 2 here, k into k plus 2 and plus 1. Here I'm getting k square plus 2k, k square plus 2k plus 1 divided by k plus 1 to k plus 2, right? So this is known as this is the term we get. After that, for the right hand side, what we'll have is, when we write in terms of k, it is like k plus 1 divided by k plus 1 plus 1, which is known as k plus 1 divided by k plus 2. So actually we'll see these two terms when we see here. When we see this LHS, we'll rewrite this one as k plus 1 the whole square divided by k plus 1 into k plus 2. So when we'll solve it, we'll get k plus 1 divided by k plus 2. So which is known as LHS equal to RHS in this case, right? That's why, hence, the statement is proved by induction method. So see here, we'll have proved for k plus 1. So this is the way we have to solve this. Thank you. Thank you for watching. We'll see in the next session.